Hello everyone, this is Gags, and in this video we're going to model this flange mount part inside of SolidWorks. So looking at the drawing we have before us, we've got a nice front view here, top view, an isometric view, and one of the first things that kind of speaks to me is the fact that this part is very symmetric about the central axis here. And so there's some tools inside of SolidWorks that will help us make the geometry here. One of the things I'm thinking of here is all the solid geometry that I'm creating will largely be created in one feature using a revolved boss and base. And so with that, one of the things we can do is, for instance, draw the kind of right half of this cross section that you're looking at here, and then revolve it about the center axis, and that would actually create the solid geometry for us. And then we can just kind of whittle it away with the series of holes we have in here. Another thing to talk about is the fact that this center hole is something that we'll use the hole wizard to create. It's a half 20 UNF, Unified National Fine, through all thread. And so we'll have to use the hole wizard to kind of get that notation inside of it, instead of just a cut extrude, if you will. Other things to note, it's a inch length drawing there. Dimensions are in inches, both a couple spots there in the title block, and then we also want this to be 661 T6 aluminum. And so with that being said, let's go ahead and hop right into the part template that I've got going. I already have IPS. Let's go ahead and set the material just in case I forget at the end. And so I just right click, I edit material. I need to go down to the aluminum alloys instead of the steel. And we're really looking for a 6061 T6 right there. I'll hit apply and close. So now we're looking in good shape. Going back to the drawing. So we want this thing to look in the isometric view here. We get the origin, you can see at the very bottom of the part. And so this first sketch, which we talked about, I'm just going to kind of model the right half of this cross section that you're looking at here, is going to be made on the front plane. That way I can revolve about in SolidWorks what looks like to be the y-axis here, looking at the triad here in the bottom left, in order to create the geometry so that it looks like this in the isometric view. So with that being said, let's go ahead and create that sketch on the front plane. And let's go ahead and first just make the sketch just like I've described, or on the right half side. I'm not going to worry about the fillets. I might put those in as a feature a little bit later. So I'll go grab my line tool and just kind of draw that rough shape. About like that, creating that nice closed profile there. So with that in place, I'm going to go add one more feature, and it's going to be a center line that marks kind of this axis that I'm going to be revolving about. And so that'll be helpful when I'm making some of these dimensions. So one way to do that is I can go up here to the line tool. Don't grab the line, but grab the actual center line. And I'm just going to go from the origin, and since most of my geometry, or no, all my geometry is going to be above the origin, I'm going to just draw straight vertically down in order to create it. So with that being said, I've got all the lines that I need to place. Now I just need to start sizing them with some dimensions that I haven't put in yet. And so let's start with this guy. Go with something with easy. 0.375 is the height of this line here. So I'll get the Smart Dimension tool going. 0.375 there. Overall height you can see is 2.5, so let's go ahead and apply that as well. So that's looking good. Now we need to start applying these kind of diameter dimensions, getting us the width, if you will, from what we're looking at. And one thing we're going to do is use a trick with the center line in order to do this. So this overall width, 4.00. One thing I'm going to do here is I'm going to click that point. I'll click the center line, and notice if I'm on the right side of the center line, it just gives me that dimension. But if I drag my cursor over before setting the dimension to the left side, notice that left-hand extension line is jumping to the other side of the part and basically acting as if it's symmetric at that point, kind of giving us that diameter feel since we're talking about kind of a circular or roundish part. And so that's exactly what I want to happen, so then I can start mimicking the dimensions that are right on the part. Just working my way up from the bottom, that 2-inch diameter here is calling out the virtual sharps, as if where these lines are meeting without that fillet. So I'll click that line, this line. I've got the one dimension here, but if I pull it over, then I get the bigger kind of diameter style dimension there. I believe that was a 2-inch there, and then a 1-inch at the part, 1-inch at the top. So again, just the same item here. Here I already had the center line selected, so it automatically jumped since that's where my mouse position was. And 1.00 there. So we've arrived at a nice fully defined sketch. You can see it says fully defined on the right hand side. Everything is black except for one point there. That's the blue point that's basically saying, hey, really I haven't defined the length of that center line. That's okay though, really that center line's just being used for the direction, or excuse me, the axis of revolution there. And so it's okay if that length hasn't been fully described. Alright, so I've got a nice fully defined sketch, a nice closed profile here, and I'm going to take this right into that revolved Boston base. And so there's my revolved Boston base. You can watch the animation that happens there. You got a 2D cross section, you select some sort of axis, and then when you go to the revolved Boston base, it's going to revolve it around that axis. That defaults to 360, but you can change the angle is what they're showing here, so you don't have to revolve it a full 360. And then whatever that yellow volume is enclosing, it creates the solid geometry. So with that being said, I'm going to go right into Resolve Boston Base. It's consuming that sketch because it was already active. And then notice it's picking line 7, which is our center line. Still had one center line in the sketch. SolidWorks is assuming that's what I want to revolve about, which is a correct assumption at this point. And then it's giving me the full 360-degree rotation preview, which again is what I want. So I'll go ahead and accept that. So there you go. We've already applied that 661 T6, so I kind of have a appearance on it. It's almost white silver. It's kind of reflective, as you can see. And so now we need to start adding on other features. One thing, just to kind of dress it up right off the bat, I'll go ahead and put these fillets in. A lot of times I put the fillets in toward the end, but this is a fairly simple model, so I don't think it'll hurt anything. It's 0.125 for the radius of those fillets. And one thing I'm going to do is I'm just going to click that face right there. You say, hey, fillets go to the edges. So what this SolidWorks is doing is basically taking that face, finding its edges, and then putting fillets on the edges there. Here, there's kind of an inside edge and an outside edge. So that's looking good, and we'll just accept that. So now we're looking pretty good, and now we just need to create the holes. So I guess I'll go ahead and start with this top hole, the one that's actually tapped all the way through. It actually has internal threads on it, the half 20 UNF through all. And so like we said, we're going to have to use the hole wizard in order to create that type of geometry, or at least that type of notation on there, without having to actually model the threads itself. And then we'd have to apply some sort of note, maybe name a feature appropriately or something like that to actually get the notation on it. Probably the more convenient way is just use the hole wizard in this case. So I'll go with the hole wizard. We have type and position tabs here. I usually start in the position tab just because I like to find the position of the hole, then I'll come back and say, okay, the hole is going to be located here, and here's the attributes of it. So with the position tab active, it's wanting me to select a face to define where the hole is going to be. So I'll just click this top face, and I'll click it right here. And what this is doing, so you can see if I go normal to, is allows me to define a point, and that point's the center of the hole. So in this case I need to fully define the location of the hole center, and in this case it's just right on top of the origin, so I'll hold control while they get them both selected, and then go to coincident, and now I'm fully defined just like any other sketch. You can see I'm fully defined in the bottom right. So that's looking good. And now, as you can see, I can create lots of different types of holes. There's a countersink hole. There's just a through hole with no threads on the inside. What I want is a tapped hole, and specifically a straight tapped hole here. I can use ANSI inch, that's fine. Let's just go to straight tapped. And I've actually got half 13 here, which is close. I need a half 20. So this is kind of the coarse thread version of what I'm interested in. And so I'll just take this down to half 20. It's right next to it in the combo box. There's a lot of different options I could configure here. And I think I'll just set the defaults on all this. hit the green check mark and notice it accepted it. And notice here right in the feature tree, I've got a nice clear definition saying, hey, this is a half 20 tapped hole. And if I look down through there, you can see it goes all the way through the part, exactly what I want. And then I've also got this appearance, I'll say, that's kind of mimicking what it would look like. The threads aren't actually in there, but it kind of is giving you that visual effect. So that's looking pretty good. And then next thing, let's just go ahead and put these holes on the bottom face. And so for that, we have to create some sort of seed feature to begin with. So whether we make the pattern of the holes at the sketch level or make a single hole with a cut extrude and then pattern the feature, either way I got to start a sketch with a seed feature or sketch. And so with that, I'm just going to click right on this top face and create a sketch. Go Control 8 to normal 2. And the first thing I'm going to do is I'm going to set this kind of radial position of these holes. And to do that, I'm going to create a circle, the diameter of 3. It's centered at the origin, but I just need it to be a reference, so I'll have to make it into construction geometry. And so to do that, I'm just going to start with a regular center point circle. Define the center here, pull out, I get the radius roughly correct, and I can come smart dimension and define the diameter exactly the way I want it. But at this point, it's that nice, solid, dark, visible line, something we'd use for a cut extrude or boss extrude. And I actually want to change that and make it kind of like that center line was before. It's just a piece of reference geometry, something I'm going to use to define other features. And so I'm going to change it by selecting it, and then I can go right up here for the construction geometry button here, or I can also come all the way over here to the pane that pops up and say, hey, I just want to make that for construction. Either way gets you the same spot. So now let's go ahead and create our first circle. I'm just going to pick this top one here. We get the dimension tied right to it. And so if I go center point circle, that circle needs to be at the very top of that arc or circle we just created for reference geometry. And my cursor is actually snapping right to that position, which is great. And so I'll drag off, create a circle of arbitrary size. You can see the diameter is supposed to be 5/16 or 31/25. That'd be 10 thousandths. So I'll just update my diameter here. It's looking good. And now I need to pattern this out. And let's go ahead and try it with the sketch pattern. So the sketch patterns are right here. I don't want a linear pattern, but instead I want a circular pattern. So I'll just go to the circular pattern. Hey, I know the entity I want to pattern is this guy. And you can see by default SolidWorks is saying, hey, do you want a pattern about the origin? That happens to be correct for what we're looking for. I do want to go all 360 degrees for my pattern. Here, instead of 4, I need to bump that up a couple, because if you notice in the drawing, we've got a set of 6 holes. So that's looking very good. And I can just accept the preview at this point. Alright, so I've accepted the preview. I feel like I told it quite a bit of information in the pattern, but this is where SolidWorks is wanting us to fully define or fully lock down, if you will, the position of these holes. And so at this point I could drag them around, so I want to make sure, for instance, this hole stays on that bolt circle. So I just said, hey, make that coincident. Let's go ahead and try this one as well. And yeah, it looks like by just defining 2 of the positions of those holes, notice it locked down the entire sketch at this point, and they're all nice and black. I've got a fully defined symbol there. So that's looking good. You can see they're all shaded in, representing nice closed profiles. And so now I can create all 6 of these holes in one cut extrude. So with this sketch still active, I'm going to come straight up into the extrude cut. If I look at it, I'm going to that top face, and I want to go through all. Notice right now that's just going down 1/10 of an inch, but I want to blow that out so they're all the way through the part. And I'll accept that geometry. Alright, so I think we've done it. Yes, that's looking very good. Material 66126, we set that, so we've got that taken care of. Now if I kind of walk back through the model, you can see all my sketches are fully defined, which is great. Then also, what did I do? I created a revolve feature, then we added those fillets, created the tapped hole in the middle, and then we created the set of holes on that bolt circle in the kind of bottom part of the flange, all in one cut extrude feature. So hopefully that makes sense as far as how we attack this model. Some of the big things to highlight here is we're using things like the revolve feature because it's very axisymmetric about that central axis. We're using the hole wizard to define the taps hole there to get that information input into the model. And then we also did some patterning at the sketch level, right, to create this circular pattern of holes at the last feature. So hopefully this video is helpful for you. Maybe you learned a couple new features and can help you when you're modeling similar parts. As always, thanks for watching the video.